Factoring sum and difference of cubes. Was that part easy to do, yes or no?
Yeah, if I did it, it would have been.
What do you want?
Here. Wow.
Okay. Here we go. Sum and difference of cubes. Any major challenges on that, guys? Okay, assuming you did. Honestly, this section, real easy because all you have to do is follow the pattern, right?
Yeah.
So whatever it is, you just like dump it in. That's easy. Okay. Some of these others over here actually might have been a little bit more challenging for you. Dale, which one of these did you have trouble with, buddy?
The graphing quadratic and linear system.
Ah, let's do it. Let's do it.
I messed up the graph every time, so I have to.
Okay, well, let's see what we can come up with here. Delta math. And let's log in using the Warrensburg. Not the RCC. Quadratic, linear. Okay. Let's do this. Graphing quadratic and linear system.
Yeah.
Yeah, I hated these.
Okay, you did what? Who?
I hated them.
Oh, well, that happens. Okay, so here's the deal. You got two graphs you got to do. Let's start with the first one. Where do I put this? I don't know. I don't know where to put that. So let's figure out where to put it. With that, we need to say, hey, opposite of b plus or minus square root b squared minus 4ac all over 2a. Are we good? So if I plug it in, I get -4 plus or minus the square root of 16 minus 4 times 1 times -2, correct? All over 2. Now, at this point, I can say, hey, here's my vertex right there, isn't it? Because it's opposite of b over 2a, so -2 comma what? Well, what do I need to do? -2 squared plus 4 times -2 minus 2. Okay. So I get 4 take away 10, -6.
Yeah, sure.
All right, cool. Great. So I got -6. So first thing I'm going to do is drag that center point back 4, down 6. Is everybody cool with that?
Is it back to
Whoop,
6?
whoop. Me no count good. Okay. So we got that. Now, but I don't have any idea how like wide or whatever this is, right? So I probably need to finish solving. Well, let's see here. What's this? That's 8, isn't it?
Yeah.
Okay. So 16 plus 8, 20.
No, negative. I can't do math.
Well, you're right on the graph though, that you be over 2, not 4.
Yeah.
What you talking about, Willis?
You put it over 4, it should just be back to -2, not -4.
Oh, I suck at life. Okay, I'll do that here in a second. Okay, so, but in this case, we got we get positive 24, don't we?
Yeah.
Okay, positive 24. Now, in this case, we would say -4 plus or minus square root of 24 all over 2. Now, what's square root of 24? Well, see here. 2, 12, 2, 6, 2, 3. So I got -4 plus or minus 2 root 6 over 2. -2 plus or minus root 6. Do we agree with that?
Yeah.
Now, the problem is, how the heck are you going to put that on this graph?
I don't know.
That's a good question.
That's nasty because that's like that's a rational number, right? It's kind of a mess. Now, what would be nice is if we had some other nice points. Well, here's the deal. Do you know where, if that is at -2, wouldn't it make sense if I could put 1 point on one side or 1 point on the other, right? What would be a super easy number to plug in that would give us another value?
-1.
That would be pretty easy, that's true, but what would be even easier than -1?
0.
Yeah, could I plug in zeros super fast and know that this point goes right up there? There we go. Now, in this particular case, did it change our shape?
No.
No, but, you know, if we could put it anywhere in jumping jacks, everybody go. Okay. So, -2, do we agree that that is correct? So, I have my solutions, which, by the way, my solution square root of 6. What's square root of 6? Okay, what's square root of 4? Good. What's the square root of 9? Good. So, where's the square root of 6? Somewhere in the middle, isn't it? Okay. So, what is -2 plus 2.5? So, positive half, right? So, about plus a half. Is that about right? Where's -2 minus 2.5? -4.5. Are we in the ballpark? Oh, that's looking good. Okay, so we're pretty confident in that, right, Dale? Now, let's do this one now, folks. Come on, little buddies. Please tell me you know how to do this one. Double click. And so we're crossing it to up 1 over 1, up 1 over 1. Everybody agree? Okay, so what do I do for my solutions? 2 solutions at, now this is where we messed up last time, right? Because I forgot to put parenthesis and, what do we got, -4, comma, -2? In parenthesis and 1, comma 3. 1, comma 3. All right, submit answer. There you go. Okay. So, what's the challenge on this one? It does take some time, doesn't it? But I literally did more than was required. And how long did it take us, even with me waiting on y'all?
5 minutes.
Maybe. Okay. Not crazy town. And do you get that vertex solution is pretty easy, right? And to plug it in and then to graph it up. Okay. Does that help, guys? Okay. Now, let's do a different way to graph this. We'll go to the next problem. I could do totally the same exact thing as I just did. Or I could do it this way. All right, so my center is at -3, -3. Right there. And for my 0, if I plug in zeros for the original, 6. There it is. Now, that's another way to graph it. That was a lot faster, wasn't it? Okay, now, how much writing did I actually have to do for this one? Not a lot, was there? Okay, not a lot. This is the completing the square method. Alex, the completing the square method. I need to do my attendance real fast. Sorry, guys, I already got called once today. I don't need called again. Why is it called completing the square? Look at like literally the little bit that I wrote up here. Tell me why it's called completing the square.
There's were different pieces that complete the square. I remember you explained in that puzzle, but I forgot the exact word.
Okay, is this something squared?
Yes.
Okay, and how can I make stuff that's squared? I have to have 2 parts that are the exact same, identical, that's right. So here's the deal. What I did was I said, can I take this, put in something to make it identical, But why did I subtract 9? That's it. I can't just like load up not, it's like a teeter-totter with a fat kid on it, right? You can't just put somebody else over here without putting another kid over here, right? So, you gotta put, if you put something else in the problem, you gotta balance it by taking it out, correct? If I did +9 and -9, how much should I change everything? Exactly? 0, that's good, okay. So here we go. Let's do the next one. Let's do the next one. I want a new problem. Okay. Now, by the way, I'm not doing it on this because why? That's linear. There's no squares in there. All right, so let's figure out how to make a square here. First things first. Ooh, yuck, this has the negative in it. That's fine. What? But you still eat the negative? Okay, that makes sense. All right. Could I do this? Just for fun, can I take a negative out? There, is that the same exact thing?
Yeah.
Okay, now, here's your first step in completing the square. You gotta make space to put your new bit in. Does that make sense? Plus blank. And we just slide that fella right on down. Does that make sense?
Yeah.
What do I do to get a perfect square? Here's what I do. See this middle term? So I take B and I cut it in half. So what's 6 divided by 2?
3.
Okay. Now I square it. And here's why. Because when I break this up and I say x plus, what was this? 3. And x plus 3 because I cut it in half, correct?
Yeah.
When I FOIL this out, x squared, is everybody cool with that?
Yeah.
3x, 3x, and then what happens when I do last times last? I get 9, don't I? That's why we cut it in half, because that's the 2 pieces that go here, and we square it because that's what last times last is. So what's the only other thing I have to add over here? -9. How come I have to put that -9 in here, guys? Yeah, to cancel out the original 9. Okay. So now what's really nice about this x plus 3 squared, that's what all of that is, isn't it? I'm going to make you stand, Alex. Now, the only thing that's a little weird is you'll notice I keep tracking my -1 down here, right? Because we took it out to make it easy. All right. So in this case, can I put it back? From here, this tells me the vertex. Where's the x part of the vertex? Probably. There it is. What's the y part of the vertex? There you go. Now, it's a little sneakier than that. Okay, it's a little sneakier than that. But that's the basics. What you guys need to be able to do first is you need to be able to complete the square. Did you complete the square in Algebra 1?
Maybe. I don't remember.
Okay. I think maybe and I don't remember are 2 valid answers. Okay? Because you may have done it. Arguably, though, they didn't spend a lot of time on it. And that's because often math teachers don't spend a lot of time on it, even though kind of huge. Kind of huge. So here's the deal.